Yogendra is going to give the business drivers relating to why we're going to 5G, what's needed for 5G, and how that is coming about in the industry. And then Raghu is going to provide the network architecture evolution picture from his perspective. Then Carrie is going to present to you some practical deployment considerations, which is very much important in trying to transition from current generation to 5G. Then Yogendra is going to come back and give some security considerations, and I will end with IP and design considerations. And at the end, we'll have some time left for question and answers, hopefully. But all along, don't hesitate to raise hands and ask questions as need be. So without further ado, Dr. Shah.
Thanks, Goblet. Thank you. Morning, everybody. Yogendra here.
Pointer is, I'm sorry.
Thank you. Thank you. So I'm going to talk at a very high level in terms of what's driving 5G systems and what is the motivation for 5G systems. You know, we're all used to 3G and 4G now. 4G has been rolling out for a few years, but it's not taken off in terms of the fullness of the benefits of 4G. And so people wonder, why are we going to 5G? So I'm going to set a little bit of a backdrop as to why we're going to 5G, what's driving 5G systems. And I think you'll find that the follow-on discussions from Raghu and Carrie will go into much more detail in terms of the implementation side of things. And so hopefully we'll sort of blend it out in terms of starting from the top and drilling it down. So if we look at what's driving 5G, it's essentially a set of use cases. And each of the use cases is somewhat distinct in its own right, but the motivation behind 5G is to be able to accommodate all of these different use cases. And they span, generally speaking, from shopping malls in terms of high-density consumers accessing wireless networks, through dense urban information, so very high density, not even sort of microcells, but picocell type environments where high density of users wanting to get access to services. And then the other area, which is sort of very different from the earlier 4G and earlier systems, is real-time remote computing. There's a set of use cases I'll talk about in a little bit more detail there that are actually driving cellular wireless technologies beyond the current 4G systems in terms of latency requirements, speed, reliability, resiliency, and so on. And those factors are really not feasible with current 4G systems because they've not been designed with those sort of features in mind. And then the final one is open-air festivals, the ability to rapidly, when there's a gathering of some sort, rapidly deploy wireless communication systems technologies in a very dynamically and agile way. So those are the sort of things that are sort of driving 5G. These middle areas are also falling into this bucket of Internet of Things or Internet of Everything that we hear about all the time these days. Essentially the connectivity of devices as opposed to people using devices on the Internet. So when we look at what differentiates 5G from some of the earlier technologies, 4G and earlier, in the case of use cases, the use case was predominantly in 2G voice services, which then evolved towards mobile broadband services. And in that vein, it was really just faster and faster throughput, and once you had the throughput, the applications figured out what they did with the data that was available. There was no underlying spirit in terms of trying to tune the QoSs for different types of applications and services, other than maybe a handful of specific applications like voice over IP and data communications and video. What's happening with 5G is the requirements are actually being set by three very diverse use cases. The first one is referred to as enhanced mobile broadband. You'll also hear us talk about EMBB, which is essentially an acronym for Enhanced Mobile Broadband. What Enhanced Mobile Broadband is basically just faster and faster throughput. So you could think of it as 4G LTE and beyond, just being able to go beyond the sort of hundreds of megabits into gigabits of communication connectivity. So in some ways, if that was the only thing we were interested in, then that could be done with evolution of 4G technologies. LTE Advanced and so on would just address that. Unfortunately, we also want to address another couple of other use cases. One is this, I referred to it earlier as the IoT. IoT is referred to in some of the standards organizations as massive machine type communications, meaning a large number of devices connected to the internet and performing some type of communications amongst themselves. And that category is referred to as massive machine type communications. And the reason for massive is because the number of devices that will be connected relative to the current hundreds of millions or billion or so devices is going to be orders of magnitude more than that. So how do you deal with the connectivity for a significantly large number of devices? And then the third use case is this ultra-reliable low-latency communications. Those ones are communication systems where there's essentially some kind of a control loop involved, and you want to be able to react to information that's being gathered from some kind of sensory device or devices and be able to react to that. So a good example of that is, for example, autonomous vehicles, ability to communicate between vehicles and with central intelligence, and being able to react to that in a quick enough way. Other areas are, for example, drones. We're all familiar with drones. So that's another area that's being targeted in terms of these real-time communications. And then a third area, just to illustrate the point, is, for example, remote robotics for medical applications. But that's just a handful of applications. The underlying theme behind them is to be able to achieve reliability, resiliency, low latency, among some of the sort of criteria. So what you can see is all of those three use cases are very tangential to each other. But 5G is fundamentally being driven by those three requirements. Now, in the fullness of 5G, it's highly possible that there's going to be many use cases that straddle between those three use cases. But those three are the use cases that are sort of driving all the factors within 5G systems. And it's anticipated that there will be other use cases that sit in between those three areas. The second thing is the spectrum that's been available for systems up to now has basically been in the sort of gigahertz range. With 5G, the anticipation is that we're going to go into the sub-100 gigahertz range in terms of the bandwidth in the spectrum. And then on the radio side, traditionally we've evolved from single radios, changing the types of modulation to get the higher and higher performance through to today's LTE standard. With 5G, we're looking at essentially multiple radio technologies. And if you look at the work that's been done in 3GPP, there are also intentions to connect with connected wired networks as well as wireless networks. And when we look at the wireless networks, it's essentially being able to cope with multiple radio type technologies that stretch back to the LTE radios, but also definition of a new 5G radio, which I'll talk about in a little bit, and the reasoning behind that new radio. But the new 5G radio is going to also provide additional sort of features and capabilities that address those use cases that I just talked about earlier on. And then finally, much tighter integration with other wireless technologies such as Wi-Fi. If we look at the network topology, essentially we started off with, in 2G, macro cells, moved forward towards sort of macro cells as well as small cell deployments. In 5G, the intention is to cover not only the small cell, macro cell area, but also some interesting architectures using mobile edge computing, and then architecturally in terms of the core network and RAN processing, looking at what's referred to as network slicing. And I'll talk about the network slicing in a little bit, just to illustrate. Sorry, go ahead.
Yogendra, I just wanted to point out that this is probably the most important slide of all today. It's kind of why we're here. And what it is as designers and developers, this community needs to know that shouldn't be waiting for 5G to actually develop something. You better darn well get in there and develop it right now, because you see the transition point there. That's where all the money's going to come in 2020. That's the return on investment there. It won't be 5G. And so that's sort of the whole point, and I think what the industry is missing as far as promoting 5G. They're actually getting the competitors to wait and not develop products, and maybe that's not the best strategy. So sorry for the interruption, but he came up with a great slide here and he presented it fabulously. Thank you.
Okay. So if we look at the radio, I said I'd come back and talk about this new radio concept. And in some ways it's a challenge, but also in some ways it's an opportunity. So this bottom line here, a new radio comes around, every 10 years roughly. So GSM was traditional, modulation technologies. Then we had the CDMA, then we had OFDM. And now we have a new radio driving the 5G requirements. And the reason for the new radio is going back to those use cases that I talked about earlier on. We've got this indoor hotspot environment where it's very much a picocell type of deployment. We've got these dense urban areas, very similar to microcells. And then you've got the traditional macro cells. And then you've got the need to address the rural community as well. So the spirit behind the new radio is to provide a very flexible radio that can adapt to this range of different environmental conditions, but also at the same time use a range of radio frequencies which are more suited to each of those environments. And being able to mix and match the radio bands with the environmental conditions is the key challenge for the new radio. But once that's done, then that new radio is essentially designed to cope with the 5G use cases that we're talking about, and opens up a huge opportunity in terms of the deployment conditions, the services that we can deliver, and some of those features that I talked about in terms of stringent latency requirements, speed, resiliency, and so on and so forth. So that's what's driving the new radio requirements. Very different from traditional radios, but a key enabler, and probably, I would say, a key opportunity, especially in terms of the audience here, in terms of developing these technologies to fit into 5G systems. And I know Carrie and Raghu are going to go into a lot more detail in terms of the underlying technologies that are being developed for the radio side. So just setting the stage there for you guys there. The next thing I wanted to talk about is how's everything going to evolve. We're evolving 5G architecturally in a very different way from traditional systems, both in terms of the core network as well as the RAN processing. And it would be unwise to just expect the system to come on and be provisioned and up and running. So the process that's been used is you've got your traditional 4G system, traditional antennas, and traditional core network with the sort of typical core network boxes that are in 4G systems today. That's eventually going to evolve towards incorporating some aspects of 5G technologies. And the first starting point is essentially to go into the architectural elements of the core network to enable existing radios and RAN networks to interface right into 5G systems. And the reason behind that is that the core network will probably come onto the market much more quickly than the radio technologies. So in terms of a gap filler, being able to take existing radio technologies and plug them right into an evolving 5G core network seems to be the most intuitive and evolutionary way of bringing in 5 technologies in an incremental fashion. I talked about this notion of a network slice. I'm going to go back to that just to illustrate what the network slice is. What I outlined earlier on is a wide, diverse set of use cases. If we took all of the requirements for those use cases and we looked at the current deployment model for the core network of essentially dedicated boxes and catered for particular functionalities as sort of outlined here. The ability to take all of those 5G use cases and squeeze them into dedicated boxes is going to be a horrendous task. One, in terms of complexity of the boxes, two, in terms of the cost, three, in terms of deployment and maintenance. So all around, the ability to use the current model of the architecture for 5G systems and the use cases behind 5G is just not feasible. So what's happened is that the operators have basically come up with this notion of a network slice concept. The concept behind that is that a network slice fulfills the requirements for a subset of use cases or use case within the 5G spectrum of use cases. And by gluing together different slices of different capabilities, you essentially get the fullness of a 5G network capability. So that's the first thing, is break up the network functionality into essentially different use cases and create a network slice, which is essentially an end-to-end network capable of catering to that particular use case. So in that example I've given here, the EMBB comes up again, is enhanced mobile broadband, the IoT, massive machine type communications, and then the third use case is the ultra reliable, low latency critical communications. So in this case, we've got 3 slices, but there's no reason why there may be other slices as well. But the spirit behind that is that that slice is an entirely end-to-end network catering to mobile broadband connectivity. Together with the common control plane functions, the whole thing essentially makes up a 5G network. So another important part of 5G is much more clearer separation of the control plane processing and the user plane processing. And then finally, and I'll talk about this in a little bit more detail later on as well, is the notion behind the slice architecture is the current internet model of using COTS platforms, servers, switches, to essentially perform computing functions. So imagine a 5G network sitting on an internet backbone with virtual machines essentially running the communication stack. All these operations, the MME, secure gateway, packet gateway, imagine those functions sitting in virtual machines in the cloud. That's the spirit behind the slice architecture. Okay. And then once we've sort of had the opportunity to bring in the core network in terms of the slice architecture, technology will evolve to incorporate the new radio into the 5G architecture. And again, I'll point out again, is this clear separation of the control path processing and the user plane processing, so that each can be catered for uniquely based on their individual needs and requirements. Standards-wise, what's happening in 3GPP? So we're currently here working on the sort of first phase of 3GPP. And within that, the focus on phase 1 has been very much on dealing with the enhanced mobile broadband connectivity. That's been the first sort of use case that's been driving some of the 5G architecture. Not that the other use cases are not important, but in terms of driving the specifications and requirements, a lot of the focus has been towards driving the EMBB, enhanced mobile broadband connectivity. And then what we're looking at is this critical timeline here of end of 2019, beginning of 2020, when the 3GPP intends to make a submission to the IMT 2020. And it's anticipated that together with the submission around that same time frame, we'll have the features from LTE Advanced Pro as well as narrowband IoT evolution in terms of what's happening with regards to 4G and evolution of 4G technologies. And then the final thing that's going to be included in that is this new radio, specifications for the new radio architecture. So if we hop on to what's happening in IMT 2020, then remember that deadline I said at the end of 2019. This is around the time when all the proposals for IMT 2020 are to be submitted, and they'll be evaluated at the beginning of what happened there? Somehow it... Sorry. So around beginning of 2020, those submissions will be sort of considered with regards to IMT 2020, and it's highly likely that the submission from 3GPP will end up, large part of it will end up as part of the 2020 milestone. I think it's automatically set timing-wise, so it's telling me to hurry up. 802.11 is still under consideration, but it's highly likely that they'll have some submissions from the IEEE as well. Okay. If we look at what's happened in terms of official versus commercial 5G, then there's 2 or 3 things that I wanted to sort of mention. Is that from the official perspective, we're driving it through the standards process along the lines of what I just articulated earlier on, which is essentially driving towards this 2020 deadline for the IMT. Commercially speaking, what's happening essentially is the technologies are evolving based on implementations. And eventually what's going to happen is that the implementations will model some aspects of the 5G aspirations. And eventually when they get deployed, the commercial technologies will line up with the standards. So we'll probably see a lot of early technologies which are not fully compliant with the standards, but eventually they will move towards compliance with regards to the standards as the standards move along. But going back to the point that Carrie was making is we can't wait around for those standards to be formalized in order to develop the technologies. So companies are essentially focusing very much on aspects of the technologies, developing on the technologies, and lining themselves up so that they're eventually compliant with the standards. This is a little bit of a dense slide, but I didn't want to dwell on it too much. It is in the slide set, so you can take a closer look at it. But where we are today is essentially, announcements and hype as far as 5G is concerned. Some companies are even advocating that they'll be demonstrating and evaluating 5G at the end of the year, and I put that very much in the hype area. A lot of it is very focused on that enhanced mobile broadband connectivity that I mentioned earlier on, so just faster and faster throughputs, but not too much consideration with regards to some of the other use cases. In the time horizon between now and 2020, I think you start seeing incremental progress in terms of some of the technologies that are coming on stream, especially from a commercial development perspective. And then I think in that 2020 to 2025 timeline, now you'll start seeing some kind of pilot deployments of technologies that are actually starting to line up with regards to the spirit and aspirations of 5G technologies. And then 2025 and beyond, that's around the time when you'll start seeing commercial handsets that are compliant with 5G, technologies that are developed with regards to 5G and the mass deployment of 5G technologies. So there's a lot of noise in the market today that 5G is around the corner. I think it'll take time to get there. You'll see aspects of 5G coming onto the market that sort of lines up towards where 5G will eventually end up, but it'll take a while. It took a while with LTE, it took a while with WCDMA. It's going to take time to get 5G up and running. I wanted to talk about 2 or 3 things with regards to 5G that's sort of driving 5G technologies. One is performance, and if you look at some of those use cases, then the performance is stretched in terms of lower latencies, sub 10 millisecond latencies for some applications. Applications such as augmented reality, virtual reality, autonomous vehicles, all demand a very high level of performance, very low latencies in terms of reactionary capabilities over a cellular link. Second one is the higher data rate and the capacity. Higher data rate is really just an evolution of enhanced mobile broadband, but the capacity is the other aspect of it, which starts encroaching on the sort of Wi-Fi type technologies. In a way, there's a competition between cellular and Wi-Fi. Wi-Fi as 3G cellular technologies should, to some extent, try and cope with some of the capabilities of Wi-Fi technologies. So a little bit of overlap there, but also competitiveness. And then the last area is, the mobility uses in terms of being able to do more interoperability between cellular and Wi-Fi, but also in terms of data aggregation between cellular and Wi-Fi technologies together. Okay. And then there's a spectrum of sort of example use cases that stretch between, I said, there was 3 use cases that were driving 5G, but there's a spectrum in between as well that drives the requirements for 5G systems. Next one is the revenue, and I mentioned Wi-Fi technology, so this is a good illustrative example in terms of what is the market size of cellular versus Wi-Fi. And clearly there's a little bit of competition between Wi-Fi and cellular. Wi-Fi technology is trying to encroach on cellular in terms of these higher throughputs in an indoor environment type of thing, as well as cable operators coming on stream with Wi-Fi type technologies that compete with cellular. And then same thing on the cellular side, trying to really come into the sort of move away from some of the outdoor type environments to address some of the video delivery services and indoor environments. I'm not going to dwell on these factors, they're in the slides. And then the final thing I wanted to draw on is, what's driving in terms of competition. AT&T, Verizon, very much competing with the cable companies in terms of providing broadband residential wireless connectivity. New higher band sort of spectrum being looked at in terms of being able to do the last mile delivery. And there's some newcomers that are sort of threatening the landscape as well, Google and Facebook. I would not dismiss any of them. Facebook has some pretty ambitious plans with their Telegraph project, which lines up with some of the 5G requirements in terms of the microcells and the macrocell deployment scenarios. And Google is doing the same. They've, to a large extent, abandoned their Google Fiber initiatives, and they're essentially going wireless. And I wouldn't be surprised if they come up with some pretty competitive technologies onto the market. So you've got the traditional players, the Verizons, AT&T, traditional MNOs. They're competing heavily with Google and Facebook, where essentially Google and Facebook are trying to drive a lot of the same use cases as 5G systems. And then you've got a couple of startups, probably many more, that are essentially trying to develop technologies that are addressing some of those 5G use cases.